Hello, geometry class. I hope you're doing well. This is our last video, the last video you will use for this semester. It's been a great semester, and these are some of the things we covered this semester. We covered the mid-segment of a triangle, perpendicular bisectors, the Pythagorean theorem, and then angle bisectors. So this video is a great review for your post-test. So with any question or anything I have, make sure you feel confident about it. So when I work out some questions beforehand, try to do them by yourself. So pause the video, look at the question, and try to do it by yourself for looking at the actual answer. Again, this is just a great way for you to test yourself before the actual post test. So some vocab that we covered was the mid-segment of a triangle. And we first did that by using our construction paper, our padded paper. We drew a triangle, and then we connected all the midpoints to each other. Well, the actual mid-segment, that is parallel to a triangle's base, and is half its length. And again, we use that formula. Well, we know that mid-segment is parallel. Those two vertical lines means parallel to its base. And that the mid-segment is going to be half of the base. Or if we're like, not a big fan of fractions, we can say 2 times the mid-segment is a triangle's base. And so through there, we did some different types of questions. A very standard question we have here. We'll do this here. Again, we know that the mid-segment, wow, that was nowhere near correct. But we know that the mid-segment is parallel to the base. Mid-segment parallel to the base. And then we're left with finding RQ. And they give us this triangle. And we notice here that this is a midpoint and this is a midpoint. How did I know this is a midpoint? The midpoint is, again, it's the middle of the point. So these two sides are the same. That means that this point must be in the middle of this line. Same thing here. Since these two sides are the same, this point must be in the middle of the two lines. And here we see, okay, one of these is the mid-segment and the other one is the base. We can see here clearly that the mid-segment is RQ and our base is SU. So I'll use that second formula of 2 times the mid-segment is going to be equal to the base. In this case, we have 2 times RQ, which is equal to SU. And we know that RQ is x minus 2, and SQ is x plus 3. So once we saw that, once we knew what the base was, and once we knew what the mid-segment was, we can just plug it in and just work from there. And now this becomes just like a standard algebra question. When I do this, I'll need to distribute that 2 on both sides. Not on both sides, but just distribute the 2. So it'll be 2x minus 4. And then from here, my goal is to get x by itself. So everything with x needs to be on one side of the equation. Everything else needs to be on the other. So I'll just move x to my left side. Doesn't really matter. And then here, to get the x by itself, we'll do the opposite operation. So we'll add 4 to both sides. So we get that x equals 7. Do not stop there. My goal is to find RQ. So I know that RQ is equal to x minus 2. And we figured out what was x. X was 7. So this tells us that RQ must be 5. This is great. And if you plugged in 7 to your SU, you would see that SU would be 10. So 2 times the mid-segment equals the base. It works out great. Again, VW with these, whoa, made my person way too big. Let me move them out of the way. Perfect. With these, again, try them by yourself. See if you can answer these by yourself. Notice I gave you extra information here. I gave you some information that you don't need. Establish which one is your mid-segment and which one is your base. So I have my mid-segment and I have my base. I had just some irrelevant information. I don't need to know this. It's telling me to find VW, which is my mid-segment. So I need to know my mid-segment and base. Just ignore this. That's just information you don't need. So again, 2 times the mid-segment That's equal to our base. So 2 times my mid-segment, which is VW, is going to be equal to my base, which is LN. And again, plug in what you know. We know the length of VW is x plus 15. And we know the length of LN is x plus 21. Now from here, again, just distribute the 2. So it'll be 2x plus 30 equals x plus 21. And these numbers are actually not that bad. We'll get x by itself, so let's move that x to the left side by subtracting. So we get x plus 30 equals 21. Now with this here, again, plug in, no, not plug in, not yet, solve for x by subtracting 30. And this is nice because this should give you a hint that you're not done. We're trying to find the length of VW. And if you had just stopped here and answered the question, you would have said that the length was -9, the length being a negative number. That should kind of throw you off a little bit. Well, remember that VW in this case is equal to x plus 15. So plug in your value of x. So in this case, we'll just do -9 plus 15. Which would get be just 6. So again, with mid-segment, your goal is just to figure out what is a mid-segment, what is a base. From there, plug in what you know. I gave you irrelevant information on this one. That will happen a lot of times. So be careful about that. We also cover some other things like a perpendicular bisector. That's the word. Can I move this all the way? That's a little bit better. Perpendicular bisector. So this is just the line that cuts a line segment into 2 equal parts at 90 degrees. Again, that key word is 90 degrees. That will kind of give us a hint as to whenever we have a perpendicular bisector. So whenever you have your 3 perpendicular bisectors meet at a point, that's called the circumcenter. Now, the reason why that's so big is because the center of the circle, such that all 3 vertices of the circle are the same distance away from the point. So that point means it's the same distance from either of the 3 vertices. So in class, we had our compass, we extended it to a certain part, and we saw that it was the same distance away. We won't really cover those type of questions for circumcenter, but you may have those questions, especially in your geometry classes here. But with this here, BC is the perpendicular bisector of AD. Find the value of x. So if they didn't tell me this, that BC is a perpendicular bisector, I would be able to tell it was a perpendicular bisector because of this right angle here. Okay? And one thing to note, this looks like it goes through this angle here. It looks like it cuts it evenly. Right now, I can't assume that this is also an angle bisector. If they gave me the little congruent marks on this picture, I can assume it's an angle bisector. If they told me it's an angle bisector, then it's an angle bisector. But I cannot make that assumption. Let's see here. Perfect. So with perpendicular bisector, that word bisector means it's going to cut into 2 equal pieces. So in this case, since we got a perpendicular bisector that is BC, we'll just set them equal to each other. And then we just work from there. So I like to have a positive x value. Again, doesn't matter. That's just up to you. And then from here, add 2 to both sides. Now this question just asks you to find the value of x. So we'll just stop here. Well, we kind of had to stop here. Perfect. Value of x was 6. Again, this is a perpendicular bisector because they tell me, but also mainly because there is that 90-degree angle on this picture. Very same thing here. Since it is a perpendicular bisector, again, that little square that tells me it's 90 degrees. We can also set those sides equal to each other. And again, I'll do this and I'll do it all in one step here. So I don't have to keep writing a bunch of different things. Again, our value of x is 5, but our question is saying find the length of hi. So hi, our high, is 3x plus 2. But we know the value of x is 5. Therefore, hi has a length of 17. With perpendicular bisector, it will either tell you it's a perpendicular bisector, or you'll see the right angle right there. And the last big thing we covered this semester was angle bisector. And then with angle bisector, we did cover Pythagorean theorem beforehand. But an angle bisector is just a line or a ray, that cuts an angle into two equal parts. And then the incenter. So that's the place where all three angle bisectors meet. Now, we use our compass and we drew a circle on the inside of our triangle, but it's just a point forming the origin of a circle inscribed inside the triangle. That's too wordy. Basically, it's the biggest circle we can make inside a triangle. Now, there were different ways we solved this, but we had to first remember how to use the Pythagorean theorem. So here, if you forgot, a squared plus b squared equals c squared. Now, c is always it's always the side that's across from your 90-degree angle. It's called the hypotenuse, and it's always your longest side. So in this case, I actually don't know what C is. And A and B are your legs. Doesn't really matter. Doesn't really matter for your legs. What do you call which? And then that's just 128. So do not say you're done here. You need to find the value of C. Right now, you only have C squared. So to get rid of that square root, to get rid of that square, you gotta take the square root of both sides. So we'll get here that C is the square root of 128. Now, if you plug into your calculator the square root of 128, you'll get a decimal, 11.31 something. You want to keep it as precise as possible. So this is where we come to our good old classical simplifying square roots. Now, there are different numbers you can do here. I know that you can do 8, just because I kind of know how numbers work. You can either guess and check in your calculator, like literally type 128 divided by 4 divided by 6, so on and so forth. Or you can just do 2, because it's an even number. Either way, I will do 8 in this case, just because, just because I know 8 and 16, right? Yeah, 8 and 16 goes into 128. From there, just break those two down. So 8 can be 4 and 2. 4 is 2 and 2. 16 is 4 and 4. And then that'll be some more pairs of 2s. Again, with this, we're looking for pairs. So we're going to circle all of our pairs. Got a pair of 2 right there. Another pair of 2. And another pair of 2. And I'm going to box up everything that remains. So this tells me that the value of C that is now equivalent to 2 times 2 times 2, and then there's a square root of 2 left over. So all the pairs, we take one of them and put them on the outside, and every number that's boxed up, so every number that's left over, we place it inside our square root. And then simplify as much as you can. So here, we know that 2 times 2 times 2 would be just 8. And then we leave the square root of 2 by itself. So yes, you will need to remember and know how to simplify square roots. Knowing this helped us out. I think this will be the next question. Yeah, it will be the next question. Well, actually, you'll see those type of questions on the post test. I didn't include exactly the example in there, but you could look back on the angle bisector video where I should work through those examples with y'all. Find the value of MK. Find the value of MK. Since this is an angle bisector, and I know it is an angle bisector because I have my congruent angles right here. This tells me that VK will be an angle bisector because I have my congruent angles right there. That's great and amazing because I can just say, and that's K, that 2x plus 1 is going to be equal to 3x minus 8. And I'll go ahead and say that MK is equal to, is that KT? Yeah, KT. And again, from here, nothing too crazy. We're just solving for x. So subtract 2x on both sides, and then I'll go ahead and move 8 on both sides. So we'll end up getting here that 9 equals x. And so MK is 2x plus 1. Therefore, all of MK is going to be 19. Perfect. And then our final question for this video is an angle bisector question. Try to get familiar with this because you'll see something very similar on the post test. Find x if measure 1 is 7x plus 5 and measure DBC is 18x plus 2. And I didn't include this on here, my bad. I meant to also include on here that BP is an angle bisector. That's important and big because that tells us that those two angles are equal. So here's the thing we know. We know that measure of angle 1 plus a measure of angle 2, if you add those two angles up, that's going to be the total angle, which is DBC. And so if we're trying to solve for x right now, we would plug in what we know. So we know that measure angle 1 is 7x plus 5. Ooh, they don't tell us measure angle 2. Okay, that's fine, I guess. And they tell us that 18x plus 2 is going to be our measure for angle DBC. Now, here you have a problem because you don't have all information just yet. You don't know what measure of angle 2 is. Now, don't panic because you actually do know the measure of angle 2. Since BP is an angle bisector, that tells us that the measurement for angle 1 is going to be the same as the measurement for angle 2. What that means for us is that the measurement for angle 1 is going to be the same as a measurement for angle 2. So instead of saying M1 plus M2, I'm essentially saying just the same thing over twice. And then from here, we're just going to simplify. So this left side now becomes 14x plus 10. And then we just solve for x. And I'll actually work out all the steps here. I won't condense it. So we get 10 equals 4x, oops, my bad, plus 2. And to solve for x, subtract 2 on both sides. We'll get here that 8 equals 4x. And then finally, if we divide by 4, we'll get that x is going to be equal to 2. So the biggest thing there, let me get my laser pointer out. Since BP is an angle bisector, we can say that angle 1 is congruent to angle 2. That means that here, we didn't know measure angle 2, but we did know the measurement of angle 1. So that's why we can say that 7x plus 5 plus 7x plus 5 is going to be equal to this whole thing here. Now with the post test, again, it's going to be very similar to this. So if you're still struggling with this content, please let me know. I can assign some extra questions, some extra practice problems, and I can make some more videos for you. But if you don't have any questions, I will see y'all later.